To today's session on getting started with .NET on AWS. My name is Taz and I'm a Solutions Architect at Amazon Web Services. In today's session, I'll be taking you through a few hands-on demos and slides to get you started in using AWS with Visual Studio 2019 and .NET Core. To do this, we'll first learn how to set up Visual Studio 2019 to work with AWS by installing the AWS Toolkits extension. We will then refactor a monolithic ASP.NET application to leverage APIs deployed onto containers hosted on Amazon Elastic Container Services and serverless functions hosted on AWS Lambda. And then we will deploy an ASP.NET MVC web application onto a managed virtual machine environment hosted on AWS Elastic Beanstalk. I will also go into detail on the services used to give a practical hands-on and theoretical view of working with .NET on AWS. So, let's dive a bit deeper into the AWS Toolkit before running through the installation process. The AWS Toolkit extension for Visual Studio is a plugin for the IDE that makes it easier for developers to develop, deploy, and debug applications that are hosted on AWS or use Amazon Web Services. You can launch virtual machines with Windows or Linux, launch and manage databases, create, deploy, and test Lambdas, and much more. Also, one of the great features is that you can deploy your ASP.NET web applications using Elastic Beanstalk services through the plugin. Also, the toolkit installs a number of new project templates onto Visual Studio to get you up and running quickly. These are project templates for Lambda, ASP.NET, console apps, and much more. We will be using a lot of these templates for the work we'll be doing in refactoring our monolithic web application. So the idea is for us to use these projects to get some skeleton code and allow us to start developing apps really quickly. So without further ado, let's jump into the process of installing the toolkit onto Visual Studio 2019. To install the AWS Toolkit extension, let's open up Visual Studio 2019. Then if we navigate to Extensions and Manage Extensions, we can search for the AWS Toolkit. Let me expand this window out a little bit, and in the search bar, type in AWS Toolkit. Okay, we can see there's the AWS Toolkit for Visual Studio 2017 and 2019. That's the one we want. Let's hit download. So cool, that's worked correctly. And what you'll see on the left-hand menu here is a series of AWS services that can interact with directly from Visual Studio 2019. Okay, so let's go over the MVC web application that we'll be refactoring as part of this exercise. So I've generated some sample code to make an application where somebody will go ahead and load a view, and the view will prompt the user to enter their first name. So once the first name is entered into the text box and we hit submit, the user will be then directed to a greetings page where they will get a customized greeting based on the name they entered, something like "Hey Taz." And also, the user will get a randomly generated weather report for their region. The code behind the scene is pretty straightforward. So we have an index view where the text box and the submit button lives. And then when the submit button is hit, a post operation occurs against the home controller, which accepts the post operation in a get greetings method, and then goes ahead and instantiates and invokes a greetings factory class. That greetings factory class then does two things. First, it goes ahead and instantiates a welcome message service class, and it passes in the user's first name and returns a string, which is a greeting. Then once the greeting string is returned by the service class, the factory will go ahead and instantiate and invoke a local weather service class. That local weather service class will get a randomly generated weather report for the user's region. The first thing we'll be doing as part of this session is refactoring the monolithic application to use microservices. And the first microservice will be used to generate the welcome message. So we'll take the logic from the welcome message service class and abstract that into an AWS Lambda function. We'll use the project templates that have been installed as part of the AWS Toolkit extension installation and use a skeleton code there, and then copy over a few classes from our initial project into the Lambda project to give some business logic to the API. Once we've deployed that out to AWS and confirmed through Postman that this works, we'll move on to the next step, which involves doing the same thing with the local weather service class. However, instead of hosting it as a Lambda function, we'll be deploying it out into Amazon ECS to run as a container workload. Once the MVC web page has been abstracted through the welcome message and local weather APIs being externalized, we'll go ahead and then rehost that application onto AWS Elastic Beanstalk. Okay, so this is the ASP.NET web application I described in my previous PowerPoint slides. As mentioned earlier, we have a home controller which accepts a post request when a user enters a name and presses the submit button. That then goes ahead and creates a greetings factory class instance and calls a getGreeting method, passing in the username from the input box on the index view. So let's have a look at the greetings factory and see what that does. The greetings factory basically instantiates the welcome message and local weather service classes and calls the getWelcomeMessage method inside of the welcome message service class, and also calls the getWeather method inside of the local weather service class as well. And then with the resulting data, it creates a greetings model, which is returned to the controller and then used as part of rendering the getGreetings view. So what we're going to be doing first is inspecting the welcome message service and then abstracting that logic into an AWS Lambda function. So let's dive into that a bit deeper. Go to the definition of the welcome message service class. So inside of the class, we have a getWelcomeMessage method, which accepts a string as an input value. Then we go ahead and test the string to see if it's not null and if it's not an empty string as well. If those conditions are met, we format a return message, and that basically uses this template up here where we say, hey, whatever the username is. So in this instance, if I have entered Taz, then we'll say, hey Taz, and return that as a string. So what we're going to be doing now is adding an AWS Lambda function project into the solution using the templates installed by AWS Toolkit. So let's go ahead and do that now. And then once that project is created, we'll go ahead and copy this welcome message service class into that project and create a controller and write some code to go ahead and instantiate this welcome message service, carry out the same business logic we have right now, and return a HTTP response with the message string inside of that. So we add that Lambda project as we would with any other project in Visual Studio 2019. So right click on the solution, press add, go ahead to new project, and then let's search for AWS Lambda. As you can see, the toolkit has installed quite a few different project templates, which I won't go into for this session, just to keep things simple. What we will be using, however, is the AWS serverless application, which uses the .NET Core framework and C#. So let's press next. Let's give this project a name. Welcome message.api seems good. Okay, and then the next step in the wizard will be to go ahead and select a blueprint that we want to use. So for our use case, what we want to do is create a web API. So we're going to go ahead and select ASP.NET Core Web API as the blueprint. Now a new project is added into our solution. And as you can see, we have a controller created called values. This is a stock standard sort of sample controller that typically gets added to a .NET Web API. And we're going to be modifying this in a second. Also, we have some scaffolded code to go ahead and allow Lambda to generate sort of the system classes it needs to operate correctly. Again, for the session, I won't go into too much. However, the AWS documentation dives into that in quite a bit of detail. What I will go into a little bit is the serverless.template configuration file. This configuration file allows us to configure our serverless function before we deploy it to AWS. We can do things like select the memory allocation for the function, timeouts. Also, as a bonus, this template allows us to automatically put our APIs behind an API gateway. What we do want to do is go ahead and make a new folder to host our business logic inside of the welcome message API project. So right click, add a new folder, and let's call it helpers. I'm going to go back to my old web app project and copy the welcome message service class, and then paste that into my helpers folder inside of my Lambda function. Cool, so that's been copied across. Now what I want to do is change the namespace of that welcome message service class to reflect my new project. So you are no longer the old web app.service namespace. You are now welcome message.api.helpers. Awesome. Then let's go ahead and look at the values controller and start customizing it for our use case. So as I mentioned earlier, what we want to do is have this API accept post requests. So where the post body will contain a username, that'll be caught by the controller, and then that'll be passed through to the welcome message service class, and then formatted accordingly and return it as an HTTP response from our controller. So I'm going to go ahead and prune out the class to remove the gets. And I'm also going to go ahead and remove the put and the post. Oh, sorry, the put and the deletes. Okay, so I'm going to cheat and use some sample code I'd already had in Notepad to flesh out this HTTP post method a bit more. Okay, so let's go ahead and get rid of some of these errors. Okay, add a using statement. Great. Okay, so what have we done? The code I pasted basically uses the welcome message service inside of this project, and then as per the previous old web app, we call the get welcome message method, passing in a username, and then if that method does not return a null, then return a HTTP OK along with the value. However, if the method does not return a string, then we return a no content HTTP response. So that kind of conforms to best practices when you think about RESTful APIs. You always want to give a meaningful HTTP response code along with the data passed back to the consuming application. So let's save that and see if this project builds. Actually, while that is building, I'm going to go ahead and load up Postman so I can test this API. All right, build successful. Awesome. So why don't we go ahead and run this function? And like most other Visual Studio projects or .NET solutions or projects, we can run this locally. So I'm going to set that as my default project and hit run. Great. So we have a URL and we also get a message saying welcome to running ASP.NET Core on AWS Lambda. Awesome. So this is quite handy for when you develop new APIs or are developing code and want to run it locally without sort of having to deploy it out to the cloud environment, just while you're learning or maybe when you're testing out new things. And so like any other .NET project, you can run AWS Lambda functions locally. And also you can invoke them locally. So I'm going to go ahead and copy this URL, open up Postman, and paste it in. So we've got a local URL and a port number /API/welcome message, which is the controller name. And as part of that request, I'm going to send through a name of Peter Parker. So let's hit send and see what response we get back. Okay, 404 not found. What am I doing wrong? Oh, I forgot to rename my values controller. So let me stop this and go ahead and rename my values controller to welcome message. Yep, I think that's a bit more meaningful now. Awesome. Save that and let's run the project again. Seems like it's good to go. And we get a message back. Hey, Peter Parker. One more time. Let's try Taz. Great. Hey, Taz. Brilliant. So we've confirmed that the Lambda function works as expected locally. Why don't we go ahead and publish that to AWS? So to do that, we don't need to go anywhere out of Visual Studio. Why don't we go ahead and step through the publishing process? So if you right-click on the project, what you'll see is that the AWS Toolkit has installed a published option to go to Lambda or to go to Elastic Beanstalk. For the purposes of this exercise, why don't we go ahead and publish this project to AWS Lambda. So hit publish, and you get prompted with a nice wizard to go ahead and work through. So we want to go and keep on using our default profile, which is a profile with the right permissions to interact with our particular AWS account. In terms of region, I would like Sydney, but you can choose whichever region you like. And let's give this a stack name. So when you give an application a stack name, this stack name is used in the backend by AWS in creating some infrastructure as code scripts through a service we have called CloudFormation. This basically allows you to automate the deployment process and has some intelligence behind deploying a project out for the first time, and also subsequently deploying out changes to the same project. What we also have to do after we've given this application a stack name is to select an S3 bucket to upload our source code into. And the reason for that is that when you deploy out a Lambda, the first thing we need to do is compress the code from your Visual Studio project and upload it into a storage area on AWS. And then when the infrastructure as code generated automatically by the publish process executes, it goes ahead and provisions the services, applies the configurations that you specified as part of your project configuration. And then once that's done, it'll pick up the source code and deploy that onto the provision environment or the provision serverless function. So in this particular case, let's call this the welcome API stack. Right, and let's go ahead and create a new S3 bucket, which will be used to upload our code. And once that's done, let's go ahead and hit publish. CloudFormation has finished the process of deploying the Lambda function. Therefore, our status is now create complete. Once the deployment is finished, if you look down a little bit, you can see the AWS serverless URL. So why don't we go ahead and copy that and add the URL to Postman to see if we can call this function post deployment. The URL seems correct. Let's change the name from Taz to Bob. Hit send. Very cool. So we have invoked the function deployed onto the cloud on AWS Sydney, and we've gotten a response saying, "Hey Bob." And for the first time, it took about 1.6 seconds. That was probably because the Lambda function is just starting up. Let's try it again. So go to Hey Taz, send. Awesome. That was 69 milliseconds, which is sort of what I expect. So I guess now that we've invoked the Lambda function post deployment to AWS, let's go into Visual Studio and see the Lambda function deployed from our IDE. So if we go over to the AWS Explorer and refresh AWS Lambda, very cool. We can see our welcome API deployed out onto AWS. And if we double click on that, we can see a couple of options for testing the function within the Visual Studio environment. We can see some configuration settings. If you remember, the memory allocation was a configuration option in the serverless.template file along with the timeout. And when we go ahead and log into our AWS console and see what this deployed application looks like. Let's look at Lambda. So go to the search bar, type in Lambda, and ta-da, we can see our welcome API. So let's click on that and see what it looks like. Okay, we can see the endpoint URL. We can see that it's running on .NET Core. And we can see that it's a serverless REST API behind an API gateway. Okay, now that we have deployed our welcome message API onto AWS Lambda, let's go ahead and carry on refactoring the old web app to abstract the local weather service onto its own API also. We'll be creating a project which will be deployed onto Amazon ECS to be hosted as a Dockerized container workload. So to do that, let's go ahead and add a new project to our solution and start the code refactoring process. So add a new project. For this project type, we want to use a web API template, which comes default in Visual Studio. Cool, ASP.NET Core Web API. And following the same naming convention we had previously, let's go ahead and enter localweather.api as the project name. Okay, hit next. Excellent. And two things to note here. First off, let's use a .NET 5 runtime as it has .NET Core support and also is currently the most recent version of the .NET framework. We also want to enable Docker, So we can run this project locally on Docker if we have it installed in our Windows environment. And since we have a .NET Core workload running on Docker, we get the opportunity to use a Linux OS. However, in your use case, if you need Windows, you have that option available to you. So just pick the OS appropriate for your workload type. I'm going to go ahead and use Linux and hit the Create button. Right, so now the project has been added to our solution, and let's go ahead and start copying classes out of the old web app into this new project. Before we do that, we're going to create two folders. A helpers folder, like we had previously for the Lambda project, and also a models folder because the service will return a model, which will be returned to the consumers of the API. So let's go and make those two folders now. Helpers, models. Right, now we're going to find the local weather service class and copy it into our API project. Local weather service. Let's copy that into helpers. Awesome. As usual, we'll have to resolve a few errors here and also change some namespaces to match our new project naming standards. So let's remove this using statement because that will have changed once we implement the model inside of this project. Okay, and the namespace is now localweather.api.helpers. Right, let's go ahead and find the weather model and copy it into this project as well. So in the old web app project models folder, weather model, let's copy that over, paste it in, open it up and also change the namespace to something appropriate, which would be local weather.api.models. Awesome. So back to our service class. Let's go ahead and insert some using statements to resolve these errors. Brilliant. And hopefully we have no errors. Great. Okay, so we imported some existing code. Now let's go ahead and modify our controller to suit our use case. And in this case, we want this API to accept get methods and return the weather model, which will be supplied by the service class. So first off, I will rename this class from weather forecast controller to local weather controller. Excellent. Open up the class. You'll notice the route doesn't have an API URI branch like our welcome message API did. So let's go ahead and add that now to keep the API URL structures similar. API /. Awesome. There's some default code which is added when the controller was created. We don't need that, so let's go ahead and remove that. And I'm going to paste in some code for the get method, which I prepared earlier. Cool. And let's add some using statements to resolve these errors. Awesome. So similar to the other API controller we created for the welcome message, we have a service class instantiated. We call a getWeather method. Let's have a look at what the method does. So the code is pretty simple. We have an enum with some weather forecast classifications in there. So sunny, overcast, raining, or thundering. What we do is go ahead and select a weather forecast by using a random selection. And then we go ahead and merge that forecast classification into a weather message. So for example, we can say the weather in your region is sunny, overcast, raining, or thundering. That then gets returned to the controller in form of the weather model object. Okay, so back to our controller. So once the model gets returned, we basically test it to see if it's not a null. And if it's not a null, we'll return a HTTP OK response code along with the data. If the object is null, then it'll return a no content found HTTP response code. Again, aligning to sort of best practices with RESTful web services. So now that we've done this, let's go ahead and deploy this application onto AWS. Okay, so let's go ahead and publish this application onto Amazon ECS. We'll be carrying out a similar process to what we had done to publish our Lambda service. However, the deployment service target will be ECS as opposed to AWS Lambda. So to publish, let's right-click on the project, and you'll see that the AWS Toolkit extension has enabled us to have an option to publish container to AWS. Let's go ahead and click that. Cool. We want to publish our release build, not the debug build, so let's select release. And also we want to create a Docker repository to host our Docker image on AWS. And this will allow us to basically recycle that container image whenever we need to, and put some sort of source control around it to track changes over time and allow us to have a repository to pull from as well. Okay, so we've got the default of local weather API as the Docker repository name. Now, what we need to do is go ahead and select a deployment target. There are quite a few options here. However, I'll talk to run task on an ECS cluster and service on an ECS cluster options. So run task on an ECS cluster basically allows us to deploy a set number of tasks onto ECS without any sort of auto healing in there by default. So if you say run 2 tasks, then I'll go ahead and run 2 tasks. If one falls over, there'll be sort of no automatic provisioning and instantiation of a replacement task. So to cater for sort of error handling and self-healing, I'm going to go ahead and use service on an ECS cluster, which basically allows us to set a minimum and maximum number of tasks that can run at any given time, and our desired number as well. And then if you fall below the certain threshold for minimum, it'll go ahead and instantiate a new task to take up the workload for a task that has crashed. So let's go ahead and select service on an ECS cluster and hit next. Oh, one more thing before I carry on is that what we want to do is also make sure that our credential profile is the appropriate one to the profile we need to access our particular AWS account. So in this example here, we had previously created a default profile, so let's go ahead and use that. And also, we want to select the appropriate region to host our workload. So for me, that'll be Sydney. So go ahead and please ensure that you're deploying to a region that's appropriate for your use. All right, next screen. Cool. So over here, the wizard is asking us to enter a cluster name. So a cluster is basically a group of tasks that run on AWS. So let's call it the local weather API cluster. Yep, seems to be spelled correctly. Next is let's choose a launch type. So there are 2 options here. We can deploy onto, or rather we can use EC2s to power our ECS clusters. So what that means is we'll pre-provision some compute, and that'll be the finite number of compute available to us. Unfortunately, the downside of that is that we have to manage virtual machines, and we have to manage scaling them up and down, depending on how much compute demand we have against ECS. Also, we have to manage patching and monitoring and maintenance of those virtual machines as well. So a good option is Fargate, which is basically a serverless runtime for ECS. And similar to Lambda, we don't have to worry about pre-provisioning any compute. It just becomes available to us through serverless functionality. So let's go ahead and use Fargate. I'm happy with the default VP CPU allocation here. And I'm also happy with the maximum memory allocation. If I had a particularly heavy workload, I'd probably go ahead and use 1 or 2 gigabytes for that. But for now, 512 should be more than enough. It's important to think about high availability for our workloads. So in this example here, I've got 3 subnets selected, where each subnet lives in a different availability zone. So as you can see, I've got Southeast 2A, 2B, and 2C as, I guess, subnets which my cluster can deploy tasks onto. And what this means is if a particular availability zone has an outage, I can rely on the fact that my workloads will be spread across 3 availability zones, therefore I'll get a good level of resilience. Hit next. Okay, service configuration. So let's call the service local weather API. And how many tasks? Let's put 3. So hit next. It's always a good idea to make sure there's a load balancer in front of your applications, especially if they're web facing. So let's go ahead and create one now. Create new load balancer. Awesome. So call it the local weather API load balancer by default, listening on port 80. This means that we can basically put some intelligence around traffic management to our APIs. Hit next. I think we'll almost be ready to publish now. Excellent. So task definition. Let's go ahead and create a new task definition, and we'll call our task the local weather API task. Each task needs a role, and that role will allow the task to go ahead and access other AWS services. Let's hit publish. So now this project is going to build, then the container image will be pushed onto the AWS container registry, and also our application will be published onto ECS to be hosted on Fargate. So let's wait for this to finish. This may take up to 5 minutes, and once it's finished, I'll go through how to look at the AWS Explorer and check how your service is operating and get some stats around that as well. Now that the publish process has finished, you'll be shown this window inside of Visual Studio. What you'll see here is the status of your deployment. So we have active, the number of tasks running on Fargate, in this case 3 because that's what we have specified, and 0 on EC2 because we hadn't selected an option to host our workloads. You'll also see URLs that will allow us to access our APIs. So if I go ahead and click on that, what I'll get initially is an error message because I have not specified my URI branches. And when I put in my branch, so API/local weather, oops, typo, local weather, I'll get a randomly generated weather report back. Refresh it. Great. Sunny. Overcast. Cool. So what we've seen here is that the request goes through the load balancer and then to our task running on ECS and returns a model for us to go ahead and consume in our application. Also, if we open up the AWS Explorer, and let me just close this window here for a second, and refresh the Elastic Container Service option, expanding it out, we'll see 2 things, the clusters and the repositories that we have available to us. So if you recall, we created a local weather API repository to host our container images. So if I double click on that, we can see we have one container image recently published out. And that is also the latest container image. If we expand our clusters and double click on local weather API cluster, you'll see the window we had initially seen post the application being published. However, what we can also do is look at the events against our containerized environment and basically get an idea of the activities which have occurred against it. Also, we'll be able to see the tasks which run as a service on our containerized environment. So we have 3 tasks running, spread across 3 availability zones. So subnet A, subnet B, subnet C, excellent. And also, we'll be able to see that these are all running on Fargate along with the memory and CPU allocation against them as well. So this is a good way to quickly have a look at the sort of definitions for your tasks and the service configurations, and also gives you a quick view on the health and welfare of your container tasks running. Cool. So now what I'm going to do is log into the AWS web console and show you similar kind of information, but from the web console itself. Once you have logged into the AWS console, let's go ahead and search for ECS. And select Elastic Container Service from the results. This will load the ECS page within the AWS console and allow us to see a couple of things. First off, we can inspect the clusters we have configured and deployed into AWS. And if we recall, a cluster is a logical grouping of services and tasks. We can also go ahead and see our task definitions and also the repositories containing our Docker images. Let's go and explore the repositories. If you'll recall, we had deployed a Docker image into a repository which we had created and deployed to as part of our deployment process through the publish method. That was the local weather API repository. And inside of there, we had deployed an image. This repository will allow you to download images onto your local machine to go ahead and test against, and even modify and re-upload. And every time you re-upload a new version of the image, that will be marked the latest, with the previous version moving down a step in its versioning. So let's go ahead and start refactoring our old web app to look at these new APIs we have deployed out. Now that we have deployed our local weather and welcome message APIs onto AWS, what we will do next is refactor the old web app to call those APIs via HTTP, and then also deploy it onto AWS to be hosted on AWS Elastic Beanstalk. So let's go ahead and start the refactoring process now. I have already created a Greetings Factory v2 class, which has the URLs for my local weather service and my welcome message service as well. It's important to note that in a real-world scenario, you should not hard-code API values or any other kind of hard-coded values inside of your code, but rather use something like parameter stores. Okay, so once this factory is instantiated and the getGreeting method is invoked, what we do first is a post request to the welcome message API, passing in the username, which then returns us a resulting welcome message. Then we carry out a GET request against the local weather API and get a data model back for a randomly generated weather report for the local area. We then combine that data into a greetings model and return it to the controller. If you don't have these URLs handy, I'll quickly show you how to find them. So for example, if you don't know what your local weather service URL is, if you recall, we had deployed this service onto Elastic Container Services. So let's go ahead and look at the AWS Explorer, find the ECES service, expand it out, expand our clusters and double click on your local weather API cluster. If you look down at the services tab, you will see there's a URL section containing a URL for the local weather API service. Copy and paste that into your application. Then to find the Lambda URL, let's go ahead and log into our AWS console and search for Lambda. Select it from the search results, and once the Lambda service page loads up, click on Applications in the left-hand menu, then find your Welcome API, click on that, and scroll down. You'll see there's a section in the form called API Endpoint, and this URL is a URL for your Lambda API. So back to our code. Let's go ahead and change the home controller to call the Greetings Factory v2 class. Save the change and run the application to start the code locally and double check that our application still behaves as expected. Cool. So enter the first name, so Peter. Submit. Excellent. We get a welcome message back saying, "Hey Peter," along with the local weather forecast and a corresponding picture for that forecast. So, "Hey Peter, the weather in your region is overcast." Great. Now that we have refactored our application, let's go ahead and deploy it onto AWS to be hosted on AWS Elastic Beanstalk. Now that we are ready to deploy our application, let's open up the Solution Explorer and right-click on the old web app project. And if you notice, there's a Publish to AWS Elastic Beanstalk option available to us, which was installed by the AWS Toolkit extension. So let's click on that. We will get a wizard to help us with the deployment process. And first off, let's make sure that we select the right credentials to talk to the right AWS account. And again, if you'll recall, we had created the default credentials profile. So let's go ahead and use that. And as usual, we are presented with a few options on which regions to deploy this workload to. And what I want to do is create a new application environment for my AWS Elastic Beanstalk application. So let's hit next. Now we'll be prompted to select the application. So we want the old web app, nothing else. And let's select an environment name. So environments are basically groupings of services that make your application run. So for example, EC2 instances, which are virtual machines that host your workload, and the associated peripherals like load balancers, for example. So let's go ahead and make an environment called old web app dev. Okay, let's check if that name is available so we can use that same URL. Awesome. So now if we successfully deploy our application, we can call our website by calling http oldwebapp-dev.elasticbeanstalk.com. So let's hit next. Now we can select the instances to use to host this workload. So since we're using .NET Core, I'm going to go ahead and use the Linux instance. And I don't need anything large for this application, so I'm going to use a T3A medium, which is a burstable instance type. And then we have the option to select whether or not this application is deployed in a highly available manner, or if it's only deployed to a single virtual machine. So if I have single instance environment selected, our workload will be deployed to only one EC2 instance that will host the workload. Therefore, we will have a single point of failure. If I deselect that option, I can then go ahead and select an application load balancer. So let's deselect single instance environment and ensure we have an application load balancer managing load between our environments. So hit next. It's really important to select a role to assign to your application. I've selected the default AWS Elastic Beanstalk EC2 role. If you are using other services like SQS or SNS or RDS, then make sure you configure a role in your AWS environment that has the appropriate but also minimal level of permissions available to it to interact with services appropriately. Okay, let's hit next. And let's hit next, and we should be ready to deploy soon. And now what I'm going to do is press deploy and start the deployment process. This deployment process should take between 5 to 10 minutes. So let's come back once the deployment has finished. Once the deployment process has finished, the AWS Toolkit extension will open a window for us inside of our IDE to give us a view of the current health of the application and also how far through the deployment process we are. We'll also see the current state of our environment. So our environment is healthy, which operating system the application is running on. And we'll also see a URL to go ahead and test our application with. So if you click on that, we can see that the web app loads correctly. It's hosted on Elastic Beanstalk. Let's enter a new name. Bob, hit submit. And we get a weather report and greeting back as well. So what I'm going to do now is show you how to look at the environment and the application provisioned along with some details against it. First, through the AWS Explorer in your IDE, and secondly, through the AWS Web Console. So switching back to our IDE, same as what we've done before, if you open up your AWS Explorer and go to Elastic Beanstalk, what you'll see is that our application has been deployed. So our application is called Old Web App. Against that application, we have an environment, which is the dev environment, so Old Web App-dev. And if we double click on the environment, you will see the same screen we've seen before. Just wait for the data to load up, which will give us the status, the URL, and also the application name, along with a few other details. And over here, we get the similar kind of data to what we've seen before. So we have an environment called dev, we have an application called Old Web App, we have a URL to go ahead and click on to go into our web page. And then if you click on the environment name, you'll see basically some events that have occurred recently against that and the status of the environment as well. Okay, so let's dive a bit deeper into some of the services we have used in this session, starting with AWS Lambda. So AWS Lambda is a serverless compute option from AWS, where as a developer, all you need to worry about is running your code in the cloud and not managing the underlying infrastructure. And so what that means is you don't have to manage or patch or monitor virtual machines. You can rely on the application being able to scale based on demand and loads. And also you never pay for your code when it's idle, as Lambda only charges you when the compute is used. Lambda functions can run in 3 ways. So we can have synchronous functions using the manner we have right now, where you can develop an API, and when that API is invoked, your function will start up and return some data. You can also have functions triggered asynchronously through events in your application landscape. An example of that could be where you have images uploaded to an S3 bucket by a user, and a Lambda function can detect that event and then go ahead and generate thumbnails automatically. Also, Lambda functions can interact with AWS services using polling methodologies. An example of that could be if you have messages in a queue, you can rely on your Lambda function, polling the queue frequently, and picking up the data in batches and processing it through. So what that means is that you can have synchronous, asynchronous, or event-based or poll-based Lambda functions invoking to carry out the business logic across the application. Lambda is charged by the millisecond, so it's quite cost effective. And what that means is that you don't have to pay for compute you don't use. And also there is a generous free tier available to us where the first million requests in a Lambda function are free. Moving on to containers, AWS has container services which can run Linux containers and also Windows containers. If you have .NET Core, you can use Windows Nano Server or even Linux servers. However, if you have legacy applications that run maybe the .NET 3 or .NET 4 runtimes, you may need to think about running a Windows Server core image for your container. AWS has two container orchestration platforms. We've talked about ECS, which is Elastic Container Service. We also have Kubernetes available via EKS, which is the Elastic Kubernetes Service. Both EKS and ECS are able to interact with Amazon Elastic Container Registry, which is a secure vault for your container images. Let's talk a bit more about AWS Elastic Beanstalk. Elastic Beanstalk basically configures the underlying infrastructure for your applications, and what that means is you no longer have to worry about provisioning instances, logging in, installing and configuring your application stack, but rather, as a developer, all you need to worry about is deploying your code out into an environment and rely on AWS to provision the appropriate configurations you have specified. Also, you may find it worthwhile to go and read a couple of these articles here. There's a pretty good white paper that's been written for developing and deploying .NET applications onto AWS. There's also further documentation on the AWS toolkit, as it's quite feature-rich, and you may want to investigate some of the functionality we haven't covered in today's session. And also, there's a really good page from AWS for building .NET applications. It has articles, blogs, and also AWS documentation available to .NET developers, which you may find quite useful when you think about writing applications which are going to be hosted on AWS or leverage AWS services. So with that, I'd like to thank you very much for attending and spending time in today's session. And also a quick note that we will have a follow-on session talking a bit more about DevOps and building CI/CD pipelines to deploy from Azure DevOps onto AWS to set up a build deploy pipeline on AWS using the code commit, code build, and code deploy and code pipeline services. Thank you again. My name is Taz, and it was really great talking to you. And I will circulate these slides out after the session.